Okay, so we're wanting to learn about how a computer does addition. So we'll start by working in the human realm, and we'll gently push down towards computers. And I'm going to start by doing kind of an easy addition, 5 plus 3, and just to take you out of suspense, we know it's 8, but I'm going to break down and to show you the steps we're going to have to take into account when we teach a computer to do this. And first off, the number 5 and the number 3, both of these numbers are going to have to be represented in binary. And so 5 is 4 plus 1, so it'll be 1, 0, 1. And 3 is 2 plus 1, so we'll go 1, 1. Okay. Now I'm going to add these together. I'll go 1 plus 1 is 2, but 2 represented in binary is 1, 0. So I'll put this over here. 1 plus 1 is 1, 0. And so what do? I mean, think back to grade school. You put down the 0 and you carry the 1. Okay. And so now I have, instead of having 2 things here, I have 3 things here. And so I go 1 plus 0 is 1, and then 1 plus 1 is 2, which I know from before is 1 plus 0, so I put down a 0, and I carry a 1. And so here in this stage I have really a 0 that's understood to be there. So I go 1 plus 1, again that's 2, plus 0 is still 2, so I put down a 0, I carry the 1, but then it's just, zeros on down, and I put this here, and so I have, again, this is 1, 2, 4, 8, and so, hey, it is 8. Translates to 8, and so we did it correctly. Okay. Now, I'm going to do this again, to kind of, it's always nice to have another example. This time, I'm going to do 11 plus 5. And 11, okay, is 1, 0, 1, 1. And 5, as you recall, is 1, 0, 1. Okay. Okay, 1 plus 1 is 2, which is 1, 0. And we go 1 plus 1 is 2 plus 0 is, put down a 0, carry the 1. 1 plus 0 is 1. 1 plus 1 is 1, which is 0. And then carry that 1. 1 plus 1 plus 0 is 2, but you put down a 0, you carry the 1. And so finally we bring it over here. Now here I want to just sort of as an aside say, if we had limited ourselves to a 4-bit word here, this would have given us an overflow. That we're doing arithmetic beyond what the system is set up for, and that does happen sometimes, and you have to watch it when you're at the boundaries and the edge cases of what your arithmetic can do. You can watch it, but here anyway, we've got paper, and paper we have advantages we don't have on the computer, and so this again. 1s, 2s, 4s, 8s, 16, and so 1 plus 11, 11 plus 5 is 16. Okay. Now, I'm going to turn over a new sheet here and show you kind of a bigger picture of what's going on. So I want to break down the process, because this process where we're, say, adding together, our 11 plus 5, we added the two numbers together, but putting it in binary as we did, we saw that in fact we were breaking down the addition process into smaller processes. So we have this first thing, okay. We had two inputs, okay, and I'll call this one, this 1 up here and this 2 down here, and I'll refer to this top one as bit 1 and the bottom one as bit 2. And so bit 1 and bit 2, they go into a process. Okay. And something happens and two things come out. Okay. Two things come out of the process. Okay. The first of these things, okay, is what we put down here. What happened? 1 plus 1 was 2, which was 1, 0, and we put down a 0. I'm going to call that came out of there, I'm going to call it S. Okay, we put down an S, but then up here we carried a number, and so I'm going to come out here and put down a C, which will stand for carry. So we have this process, this device here. It takes in bits and it puts out bits. So we've got this device here. This device has a name. Okay, it is called a half adder. Okay. Called a half adder because the electrical engineers that created it were geniuses in nomenclature, because I bet you can guess there is eventually something coming that's called a full adder. Okay, this is a half and it's made of two half adders, but let's just think of the half adder at this point. And I want you to think of it as like a computer chip, okay? A computer chip that has wires coming into it and wires going out, that it gets information from someplace and it shares it with another place, okay? And so given that, I also want to kick in, okay, there's a truth table here. So let's take an idea. We have bit 1 and bit 2 coming in, and going out will be S, okay, for the sum, and C for the carry. And we have all manner of things that can go in. We can have 0, 0, 0, 1, 1, 0, 1, 1. If you write them down in a different order than this and put them on homework, it drives me crazy. Okay, I've just given you a little power over me by telling you that, but to use this power wisely. Okay, now, so we got 0 plus 0 going into my half adder. Well, the sum is going to be 0 and the carry is going to be 0. Well, 0 plus 1, okay, you will put down the 1 and we'll carry a 0. 1 plus 0, we put down a 1 and we carry the 0. 1 plus 1, we put down the 0 and we carry the 1. And this is the truth table for the half adder. Okay, well, in addition to the half adder, there's something called the full adder. And we've already applied this. We used the half adder on the first step. But on the second step, when we did, okay, we put down a 0, we carried the 1. When we did this addition right here down this line, we had to use a full adder to do that. Okay. Difference between a half adder and a full adder is a full adder has 3 inputs. Okay. It inputs the carry bit and bit 1 and bit 2. Okay. They go into our black box, which is the full adder, and we'll also have 2 outputs. Okay. The outputs, we'll put down the S. Okay. So 1 plus 1 plus 0. Our sum is 0, and we'll have a carry out. So we still have 2 outputs. Okay. But we have we have 3 inputs this time. And so we can also make a truth table for it. Let's do this really quickly. B1, B2, and I'll call it a CN over here for carry in. And my outputs, I'll put S for sum and C out for carry out. And 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, let's see, this will be 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are our inputs. And our outputs, okay. Okay, if we add 3 zeros together, we put down 0, carry 0, 0, 0, 1, this will go 1, carry a 0, 1, carry a 0. Okay, I'm adding 2 ones, this is 0, carry a 1. Okay, 1, 0, 0, this is 1, carry a 0. Okay, 2 ones in here, I'll have put down a 0, carry a 1, and same here. And the last, when we have all 3 of them at ones, we put down a 1 and we carry a 1. Okay, and so this will be our truth table for the full adder. Okay, and so the question in your inquiring mind right now is, how do we combine 2 half adders together to get a full adder? Before we can do that in an understandable diagram, we're going to have to learn a little bit more logic. We've learned some logic in class before. We're going to have to now do some kind of application style logic. All right.